Hi folks, welcome back to more trig fun. Today we're looking at angles in standard position. So these are angles that are on the coordinate plane, and positive angles in standard position are measured counterclockwise from the positive x-axis. So here's what that means. If you had 70 degrees, you'd start at the positive x-axis and you'd go up until you made a 70-degree angle. If you had 210 degrees, well, you'd start at the positive x-axis and you just keep going. So there's 90 degrees, there's 180, 210 might be around there. And notice I went in a counterclockwise direction. If you have a negative angle, then that means you just go in a clockwise direction. You go in the opposite direction. So here would be negative 90 degrees, negative 120 is around here. And this just allows us to define angles on the coordinate plane. Now, sort of tucked in here is this idea of reference angles. Reference angles are the acute angle, or the small angle, that's formed with the x-axis. So here, we'd be talking about that kind of angle. If you think about that angle of 210 degrees, it would be 180, and then this little extra 30 degrees here. On the negative 120, well, you'd have this extra little bit here, and that's our reference angle that I'm writing as theta r of 60 degrees. And if you're in the first quadrant, well, then the reference angle and the angle itself are going to be the same. Angles that have the same reference angle are going to have the same trig values, but the sign, S-I-G-N, like whether it's positive or negative, is going to change depending on the quadrant. And we'll take a look at that with a couple of examples. So in order to get an idea of what's happening, I want to draw a unit quarter circle, and I'll just have it pop up. There's a unit quarter circle. It contains lots of great information, allows us to change between degrees and radians, tells us that the x values on the unit quarter circle are going to be equivalent to the cosine of the angle in standard position. Y is going to be equivalent to the sine, and y over x, that I'm going to do in a different color here, is going to equal the tangent. And honestly, I like to just put my tangent values on the outside. So 0 divided by 1 is 0. A half divided by root 3 is 1 over root 3. And this would just be 1, and this will give me root 3. And 1 divided by 0 is undefined. So these are all tangent values in red. Values in red. A couple of things to note here. Number one, there are some equivalent fractions. So if you see root 2 over 2, that is equivalent to 1 over root 2, because you could find out that they're the same decimal, or you could rationalize the denominator and turn them into each other. And similarly, 1 over root 3 can also be written as root 3 over 3. Okay, so there's just a couple of possible alternate ways you could see some of this stuff. I also want to think about the unit full circle. So if I drew the whole thing like this, it would give me, these key points that are easy to pick out on the unit circle. And they tell me about sine and cosine at those values. It also lets me know a few things about where our ratios positive. And when I say ratios, I mean sine, cosine, and tangent. And so our standard primary trig ratios. In this first quadrant, they are all positive. Sine, cosine, and tangent. In the next quadrant, only sine is positive because y is going to be positive, x will be negative, so y over x will also be negative. In the last quadrant, or the fourth, only cosine will be positive because we'd have positive x's but negative y's. And in the third quadrant, tangent would be positive because even though x and y are both negative, y over x would therefore be positive. So sometimes people think of this as ASTC. Tells us which ones are positive. All in the first quadrant, sine in the second, tangent in the third, c in the cosine in the fourth quadrant. I like the little mnemonic device that all silly turtles crawl, but you can have whatever you want there. Okay, so what does this get us? It gets us an idea of how to find trig ratios for any angle on the unit circle, even though we only have the quarter circle. So if I thought about sine of 150, let's draw this down here, and I'll come back and get the rest of this question in a sec. 150 looks like this. okay, in standard position. And if I thought about 210, 210 looks like this in standard position. But both of these angles have a reference angle of 30, or sort of a buddy angle. That's the angle that they make with the x-axis. So they're both going to have something to do with whatever's going on at 30 on this unit quarter circle. Now the sine at 30, you can see right there, it's going to be a half. So sine of 30 is a half. That means the sine of 150 is also going to be a half. And because it's in the second quadrant, where sine is positive, it's going to be positive a half. Whereas sine of 210 is going to have the same reference angle, so it'll have the same sine as 30. But let's check it out. It's in the third quadrant. Is sine positive in this third quadrant right here? No, sine's only positive in this quadrant and this quadrant. Here, in third quadrant, sine is negative. So that means we get negative a half. Now you can check this out on your calculator to make sure that those values are correct, but the sine of 210 really is going to be negative a half. Last year we looked at ambiguous case with the sine law, but it turns out that once you go beyond 180 degrees, all the trig ratios have multiple places where they're going to show up. So sine of 30 is a half, but also sine of 150 is a half. Sine of 210 is negative a half, also sine of 330 is going to be negative a half. That idea is going to allow us to explore trig equations, so equations where the unknown is an angle and there's a trig ratio involved. So if you see the equation sine theta equals negative root 3 over 2 for this domain, okay, so this is just a domain, it's not telling you like what the equation is, it's just asking what angles between 0 and 360 have a sine of negative root 3 over 2, question mark. Well, let's see, sine of root 3 over 2, that happens right here, because sine is y value. It happens at 60 degrees. Okay, let's forget about the negatives. So it means that we're talking about a reference angle of 60 degrees if we were talking about a sine of, again, root 3 over 2. Okay. Once we know that, we've got to ask, okay, well, what quadrant might it be in? This is a sine of negative root 3 over 2. Could it be in the first quadrant? No, they're all positive in the first quadrant. Could it be in the second quadrant? No, sine is positive in the second quadrant. So it could be in this quadrant or this quadrant. Let me just draw that without the A and the S there. Okay. And the reference angle is 60 degrees. So these are the two angles that it might be. So let's just figure out what those are in standard position. This first one over here, this green one, would be 180 plus 60, or 240 degrees. That's an angle that I think has a sine of negative root 3 over 2. Let's get the other possible angle. I'll do it in red. So this one, let's see, that's a little less than 360. So 360 minus 60 degrees is 300. And you might have another way to think it through, but try as much as possible to use those reference angles. Those, I think, are the answers to my equation. Now, how can you check an equation? You can just throw it in your calculator and see what happens. So let me try that angle of 240. I'll see if sine of 240 really is negative root 3 over 2. So I'll type in sine of 240. I am in degree mode. It says negative 0.866. I guess I better figure out what negative root 3 over 2 is. Negative root 3 divided by 2. Oh my gosh, they're the same thing. So it's decimal approximations. I wonder what the sine of 300 is. So there's some ironclad proof that we have correctly solved this equation. And we found both of the angles that are going to give us this sine of negative root 3 over 2. I'll circle my answers and move on to the next question. So we did the process, but we never talked about, sort of what the process is. So here we go off to the side. It says steps for solving trig equations. This is what I think you should do. you should use a graphical solution if possible. So that last one, we could type in sine x, and we could type in negative square root of 3 divided by 2. And I am in degree mode. I'm going to have to think about my windows, though. My window can go here from 0 to 360. That's what I was hoping for in degrees. And because it's just a sine graph, it's going to go only down to -1 and up to +1. Okay, let's see what happens. Oh my gosh, there it is. And you can see that there's going to be an intersection at about 240 and about 300 degrees. However, we may not always have our GDC, and also we don't get exact solutions necessarily. We probably will in degrees, but we'll have a harder time in radian. So if you can't use the GDC, here are some good techniques. Find the reference angle, choose your quadrants, and sketch your answer, and then write your solutions. So we're going to do the exact same question that we did before, but we're going to do it in radian mode. So I knew from my unit quarter circle that right over here I have the point 1/2 root 3 over 2. Okay, that's at 60 degrees or pi over 3. You probably want to have a unit quarter circle with you as you're doing these. That tells me that the reference angle, and I'm going to be brave and work in radians here, is pi over 3. I'm going to get the same answer I got before, but we want the practice of working in radians. Sine is negative in this quadrant and this quadrant. Let's see, AS, TC. Yeah, it's positive in the first two, negative in the second two. So let me sketch this. My sketch doesn't have to be amazing. So there's pi over 3 and pi over 3. Those are my reference angles. Think about what we did last time. Last time to find the answer we went, oh, it's 180 degrees plus this extra little bit. Well, this time we may need to think, hold on, 180 degrees, that's pi radians. So in this case, we're going to go pi plus pi over 3. Okay. And to add fractions together, it's easy. You just make a common denominator. So think about that pi as 3 pi over 3. And that'll give us 4 pi over 3, which is 240 degrees in radians. The other one, oh, let's see if I can undo that. It wanted to make a circle. It's this far. So what can I think of that as? It's like going all the way around the circle, but then backtracking a little bit. In other words, it's like 360 degrees, or 2 pi, minus that reference angle of pi over 3. Now I'm going to have to rewrite this as a fraction over 3. 2 over 1 is the same as 6 over 3. That'll give me 5 pi over 3. Same answers, but this time in radians. You might be saying, well, could I just do it in degrees and then convert at the end? Sure, but the more that we work in radians, the more comfortable we'll get with radians. So there are your steps. Find theta r, choose the quadrants and sketch, and then write the solutions to solve a trig equation. So we'll solve two more here. We've got tan theta is root 3. So let me head back up to my quarter circle. Oh, there it is. And helpfully, I put all the tangent values in red. I think you should probably just do that and have those memorized. And we're still talking about a reference angle of 60 degrees, okay, because there's our root 3. So the reference angle is 60 degrees. We're working in radians here. And we're working in the first revolution from 0 to 2 pi. Okay, now I have to choose my quadrants. So I found the reference angle. What quadrants might I be in? Well, let's see. This is positive root 3, so I could be in quadrant 1. Or I could be in quadrant 3, where tangent is positive. There are my two answers, okay, at least as a picture. And what are their measures in standard position? Well, the first one is going to be pi over 3. And the second one over here would be pi plus pi over 3. And again, I'll just have to go to a common denominator. We can do this. It's no big deal. And add them up. 3 pi plus 1 pi makes 4 pi over 3. This is the same as saying 4/3 times pi, but we'd prefer to see it as just an improper fraction. Okay, one thing to notice about tangent graphs, and it's not a big deal, but if you want a little sort of shortcut, is for tangent graphs, we already know that their functions recur every pi units. So on tangents, it turns out that if you find the first one, then for a basic tangent graph, the next solution is just going to be pi units later, which is what we found, pi plus pi over 3. One last one. We got cos theta equals -1. And what I'm going to suggest here is that when sine or cosine have values of 0, 1, or -1, then we're on the axes. And that means that the idea of a reference angle is a little bit confusing. A reference angle can be confusing. Reference angle can be confusing. Let me show you what I mean. If I had cosine of -1, well, I'd think, okay, so 1's the value here, and then I'd go up to my unit circle and say, where's cosine 1? Aha, it's right here. It's a reference angle of 0. That's weird. If you have a reference angle of 0, then you're not really in any quadrant. You're straddling some quadrants. So what may be easier if we have sine or cosine values of 0, 1, or -1 is just draw a rough unit circle. Okay, the whole thing. But not one that you put a lot of time into. Okay, so there it is. And on this, here would be the point 1, 0, 0, 1, -1, 0, and 0, -1. And I apologize for the diagonal looking axes there. That's not great. Okay, so which one of these spots corresponds to a cosine of -1? Well, on the unit circle, x is cosine. Okay, so we must be talking about this spot right here. And what is that as an angle? Well, it's 180 degrees. But oh no, we're supposed to do this in radians. 180 degrees is pi radians. So we can go back and just write it in radians, as long as my pen comes back to me. There we go. Theta is pi. Okay. And again, we can check in a calculator if we have a calculator, though if we had a calculator, we'd probably just solve graphically. Let's go and check this. I'll put it in radian mode. I'll type the cosine of pi, and I will cross my fingers that I get -1. And we do indeed. So we know that the answer that we got is correct. So in terms of practice, let's head to page 517. We'll do number 1, 2 ACF, 3 ABE, and then 4 has some equations for us. Again, to recap, to solve equations, find theta r, choose quadrants, write solutions. And to do that, you will probably need to have a quarter circle at your disposal. Good luck with the material, folks, and take care.